Hello! In addition to admiring Winnipeg's newest attraction, the Human Rights Museum, we, Annika, Christina, Victor, and David, will be guiding you through a biomechanical analysis of amateur BMXer Seth as he jumps off a ramp at varying speeds. Why, you may ask? So we as amateur biomechanists may better understand two very important variables, velocity and horizontal displacement. Theoretically, the faster Seth bikes off the ramp, the further he will travel. Inversely, the slower he bikes off the ramp, the less distance he will cover. Therefore, we hypothesize that this will be the same during the experiment. Now I know you must be wondering, what is velocity and horizontal displacement? Well, no worries, because when this video is up, you'll be just about as knowledgeable about velocity and horizontal displacement as our good pal Rob.
For this experiment, drag and lift forces are negligible. To better emphasize the correlation between speed, velocity, and horizontal displacement, we are comparing a number of jumps at different speeds. Velocity is basically how fast Seth is going, the direction he is traveling in, and for how long. Distance traveled is defined as the measure of length of the path of an object from its starting position to its end position. Horizontal displacement is how far he travels from the start of his jump to his landing. In our case, the distance traveled and the displacement are the same. We use the video analysis program Canovia to analyze the video. We use the axis of the back wheel as the reference point. When measuring the distance, our reference point from the back wheel, leaving the ground, to the back wheel, contacting the ground again. The wheel base measurement is 32 centimeters, and we use this to calibrate the displacement. The video was recorded at a shutter speed of 240 frames per second. On Seth's first jump, his horizontal displacement is 1.7 meters, and the time it took was 0.556 seconds. To calculate velocity, we use the formula velocity equals displacement over time. In this case, 1.75 meters divided by 0.556 seconds. Seth's velocity on this jump is 3.14 meters per second. Seth's second jump has a horizontal displacement of 3.04 meters with a time of 0.742 seconds. His velocity using the velocity formula is 4.09 meters per second. Seth's third jump has a horizontal displacement of 3.10 meters with a time of 0.762 seconds. His velocity is therefore 4.07 meters per second. As we can see in our video, Seth's horizontal displacement, how far he traveled in the air, is dependent on his initial velocity at takeoff. We know this because in the first video, Seth's velocity was slower and his horizontal displacement was smaller than in his second jump and third jump. Once Seth is in the air, he is not able to increase or decrease his velocity or his displacement. Therefore, based on these observations, displacement is dependent on initial velocity at takeoff. To increase displacement, we must increase the initial velocity, which also decreases the time in the air. This principle applies to more than just BMX and bike. It is applied to several other sports, such as long jump, pole vaulting, soccer, basketball, and volleyball, among others. If we want to ensure that the displacement is increased, initial velocity must be increased. These principles help ensure technique improvement, injury prevention, and increased performance in sports.